Hi everyone. We will be waiting 2 to 3 minutes before starting the webinar to accommodate for the rest of the attendees who are in the middle of connecting. Okay, welcome everyone. I'm Heike Ritter and I will be your host for today. Thanks for joining us and thanks for being part of our community. A few reminders before we get started. Please note that this webinar is being recorded and will be shared publicly. We will be posting this recording on our community at aka.ms/security-webinars. During this time, please feel free to ask questions at any time by typing them in the live event Q&A window by clicking on the Ask a Question button. Be aware that any questions you post will be publicly available. However, if you prefer, you can post your question anonymously by checking the box right below where you can enter it. We often get many questions on these webinars, and we will do our best to respond to all of them in real time. In the event, if the answer was not provided or if you have additional questions post this event, please don't hesitate to raise them on the Microsoft Threat Protection Forum at aka.ms/mtptc. If you're listening to this after the fact as a recording, that's also a great place to ask a question. We love to hear your feedback on how we can improve these webinars. You can do so at aka.ms/security-webinar-feedback. While you are here, please join our community by also visiting aka.ms/security community. That's the best way to ensure you don't miss any future webinars or major announcements. On our community, you can speak directly to our engineering teams that create our security products. And you can do so for Microsoft Threat Protection at aka.ms/mtptc. We believe that the best way to improve our products is by removing any barriers between you and the people that create them. So we hope you will join us. I have an exciting topic today. Michael Malone will kick off the second episode of the series. So today it's episode 2 out of 4, and Michael is a principal program manager within our customer experience team in MTP. And without further ado, I will turn it over to you, Michael. The floor is yours.
Thank you, Heike, and welcome back, everybody who's able to. We have an error on the slide that says episode 1. Sorry about that. This is episode 2. Join. So, This is continuing the Tracking the Adversary series. So last week we were talking about the fundamentals of KQL. So this week we're going to be assuming that you have sort of that fundamental KQL background, and we're going to talk about a bunch of different ways to join together tables and join together data sets, including some functions such as unions, a bunch of good stuff coming today. And 1,000 internet points to anybody who got the Edgar F. Codd reference without having to look it up on the internet. This is a really key episode because this is joins are going to be how you really do a lot of your visualizations and a lot of your interpretations of your data. And it's important when we start getting into summarizing, pivoting, and visualizing data in next week's episode of Tracking the Adversary. And once again, episode 4 is going to be where we're going to go through an actual incident hunt and use a bunch of these techniques we've learned in the first 3 episodes to apply it into a real incident scenario. Just like before, we're going to have no slides for this particular one, other than this little introductory slide. So let me go ahead and get my query window up. So a couple things before we get going. I once again want to reference, we have the language reference here. So this is the reference for Cousteau query language, or KQL. It's the actual syntax we're going to be using, as well as you've got the advanced hunting reference. So this is going to describe the schema. Now, to make things a little bit cleaner, this may look a little bit different than your window. I've hidden the tables off to the sides. We have a little bit more real estate to show the actual data and the results. If you want a copy of these queries, https aka.ms/trackingtheadversary. That'll take you right to this folder. Each week before we do the episode, we're going to be uploading a copy of the CSL file, which is our query file, so you can play along at home if you want. But feel free to download a copy. This is a great way to get some good sample data for hunting inside your own MTP instance. All of the queries we're going to be talking about today will run in any MTP instance. The only thing the only one that's a little bit different is going to be when we get into the actual 4th episode where we're performing the hunt. Only because in the 4th episode we are going to be tying to specific entities that we come across in the incident. So let's get things started. So to get started, so joins. So what a join is it's going to link 2 different data sets together based on a common key. So the common key is going to either be, for example, a device ID, maybe a user ID, or maybe a file name or a file hash, something that's in common between 2 different tables. These tables can be tables in MTP, or they can be the results of functions. There's a bunch of different types of data sets that you're going to be able to link together. Again, joins are used for tabular data sets. If you remember from last week, we talked about scalar, which means you have basically a single instance of a value. And tabular, which is where you have sort of like a spreadsheet, a table, if you will, 2-dimensional. You have rows and you have columns. So joins, this is going to be primarily focusing on these 2-dimensional data sets. Now, when you're performing joins, there are a couple things that we're going to want to keep in mind around performance. Specifically, if you have a smaller table, like let's say one of the tables you're going to join has 50 rows and the other one might have 100,000 rows. Where possible, you're going to want to keep the smaller table on the left. We'll go into what the left table is in just a minute, but that will help your join performance for sure. Also, if you join too large of a data set, you're likely to encounter an error. There are memory caps and processing caps just to make sure everybody gets a good consistent experience with Microsoft Threat Protection. So if you do encounter an error, consider reducing the number of rows. And there's a couple of tricks. If you remember the where clause we talked about last week, or the take, or the top, there's different ways you can reduce the number of rows that go into the join. So you'll want to do that ideally before the actual join itself. So let's take a look at, we're going to start out with the identity logon events table. So this is a new one. We didn't talk about it last week. And essentially what the identity logon events table is it's a table containing authentications that were performed against an on-prem domain controller, so an on-premise Active Directory, or a Microsoft online service. This is not quite the same thing as a device logon event, which is where you have a logon to the device itself, because many of the device logons could be using local accounts or local security principles, which aren't in Active Directory. So this is specifically looking at Active Directory as well as Office 365, Azure Active Directory, those locations for identities. You'll also see we've got information just like before, success and failure, as well as some details about the specific logons. You can see which IP address it came from, especially this is with a cloud service, for example. You'll get ISP, you'll get the location. These are country codes. So a bunch of good information about each individual logon. We're also going to use the identity info table. So if you remember from last time, identity info is sort of a snapshot of Azure Active Directory where we can see the different users. So we're going to take, let's say we wanted to figure out where users from the finance department were logging on from. So we can take the identity info table, apply a where clause on here, and say where the department is equal to finance, and then we're going to do a join on the identity info event, the identity logon events table using the account object ID. Now, when you are working with identities inside of NTP, this is probably the best identifier to use. You can use user principal name or domain and the SAM account name, essentially. The account object ID is sort of a global identity that references, it kind of links together your cloud identities and your on-premise identities for that particular user. SIDS would work as well. But in this case, since we're linking together stuff from the cloud for a cloud logon, we're going to use the account object ID. Now, the way this works, this is essentially going to take every row that we've got that comes back from identity info, where the user is in finance, and then join it. We're going to look for rows in the identity logon events table where that account object ID matches. So in this case, you're going to see, like for example, here we've got this BA Morel came back as one of our users, and we're going to see every logon that BA Morel has performed according to the identity logon events table. Once again, keep in mind, these are chronologically based. So in this case, we're searching just the last 7 days. You can go back up to 30 days in advanced hunting. Beyond that, you're going to need to look into the actual device timelines for Defender ATP or other sources. Now, when you do a join, this is a little bit different than SQL. So unlike SQL, where it kind of links the columns together, you'll notice that we have these columns that come back that have account name 1, account domain 1, account UPN 1. So what happens is if you have a column that matches in both tables, you will get both of them back. The right table, so essentially, we'll break down what the left and right table is here. So the left table is going to be what comes before the join statement. So this is your left table. Your right table is going to be the part that comes after the join statement. So what you're seeing here with these ones are because there is a column called account name, account domain, and account UPN in both of these tables. The ones with the 1 after it in this case are going to be an identity logon events. This is a good example of where you might want to use a project away statement or maybe even a project rename statement. So if you wanted to clean up the output so you don't have duplicate columns, there's a couple different techniques you can use to clean that up. So as I mentioned, the left table in this case is going to be the identity info where department equals finance, and the right table is going to be our identity logon events. So as long as the join column names match, it'll work out nicely. But what happens when you want to join two tables together, but the column names perhaps are not the same? So I'm going to do kind of a silly example here to demonstrate this. So we're going to actually explicitly rename one of our columns. So I'm going to take account object ID and call it obj ID. So now the identity info table is not going to match the identity logon events table based on column names. So what we can do here is you can specify $left.obj ID. So specifying this column is equals. Remember, this is formal logic, so this is a double equals here. The $right.account object ID, because that's what the original name of this column was. So if you have a scenario where you want to join different columns together and they don't match, you have a couple of options. You can either rename the column. As you can see, in this case, they're actually renamed it to make it not accurate, but you can rename it so they do match. Or you can specify $left and $right. You can also specify, if you're using the left and right type of terminology here, you can do multiple operators as well. You can say $left dot account name is also equal to $right dot account name. So in this case, both of these terms will have to match. So we might get a few less results because if there's for some reason the account name does not match, but the account object ID did match, it would filter out because we're using an and we're actually specifying two terms for the join now. So this is probably one of the most important sections here we're going to get into. We're going to talk about the default Cousteau join. So the default Cousteau join is not an inner join. It's what's called an inner unique join, which means it's going to deduplicate rows based on the key on the left table. Now, it sounds a little confusing, but I'll explain what happens. So we've got a couple of example tables here. So our left table has got hello in a couple different languages, and our right table has got world in a couple different languages. Now, we're going to join them together based on the key and see what the results come back as. So we've got 5 rows and 5 rows here, but if you notice, we only have 5 rows that came back. We're missing hola and we're missing ciao. So what happened is when you use the default Cousteau join, it's going to take whatever this column is you specified, so key, and deduplicate the left table. So as you can see, our keys have duplicates here. We've got 2 zeros and we have 2 ones. So KQL is actually going to strip out that second and all the way down to however many duplicates we might have for that particular key, and only return you essentially the first value it comes across from that query before linking it together. This is done for performance reasons, but in some cases, this might cause data loss. So it's something to think about when you're performing your joins in KQL. If you feel like you're missing data, see if you're using the default join. So scrolling down here, so there is a way to get around this. So let's say you want an inner join explicitly, which is where you have all rows from both sides. You can actually specify kind equals inner. So specifying kind equals inner is going to bring back all rows from the left table and all rows from the right table. So let's take a look at this one again. So we're going to take device info where the OS platform is Windows 10, and we're going to join on the device ID, and we're going to join it to the device logon events table. So in this case, we're going to bring back logon events on the device when the device is a Windows 10 box. So this is an example of where you actually probably would want to have the default Cousteau join, because we know device info is going to contain duplicates. Each check-in from the device is going to register a new row in the table. And if you remember from last episode, it's a write once, read many platform. So it's going to keep appending to it. So we really only want to see one representation per device. Since we're joining on the device ID, it's only going to show us one row for each device ID, which means one device where this filter matched. Now, for inner joins, let's say we wanted to get all rows back. So if we run this query here and we specify kind equals inner, you'll notice that we now have all of our rows. So hola world, we've got hello world, hola mundo, hello mundo, all the rows that we would normally expect from a typical inner join. So if you want to change the join type up so you get all rows from the left side, be sure to specify kind equals inner. That'll help you get around that issue. So let's take an example where we use the inner join. So let's say we wanted to find any network communication which occurred within a 5-minute period of an alert event on a device. So in this case, we're going to take alert evidence, which is going to contain, it's going to have a row for each individual evidence that we come across for an alert. So this could be a user account that we found associated with an alert or a device associated with an alert. In this case, we're going to filter out so it only has rows that have device ID. So basically, where we have a device associated with an alert, we're going to rename the column timestamp to alert timestamp. That way, we can remember what that column is. We can also do this technically by doing timestamp and timestamp 1. This is a little bit more readable if you use this approach, though. So we're going to then do an inner join on the device network events table. So if you remember, device network events is whenever you have an inbound or outbound network connection or connection attempt to a device. And we're going to join that together on the device ID. Now, if we didn't use an inner join here, we would not see each alert for the device. We would only see one alert for the device. But because we're using an inner join, we're going to keep these alert IDs to the actual device ID mapping so we can see all of them. After that, we're going to use a sort of a fancy way to check for events that happen around the same time as another event. So we're going to use a where clause that says where the timestamp of the network event is within a 5-minute period of the alert timestamp. So as you can see here, we're using the between operator, which is going to give you the like a range capability essentially. And we're going to use a function here called datetime add. So datetime add lets you add or subtract a certain portion of time from a specified datetime object. Typically, it's going to be your timestamps. So in this case, we're going to subtract 5 minutes from the alert timestamp, and we're going to use this little double dot here, this sort of like an ellipsis, if you will. And we're going to say we're going to add 5 minutes to the alert timestamp. And as you can see, we've got rows here. So the left-hand side of this table that came back is all the alert information. So we can see what the alert ID was. We can also join this with alert info if we wanted to actually get the name of the alert. And if you scroll over here to the right, you're going to see all the actual network connection information. So now we can see which processes fielded a network connection within 5 minutes back or forth of a specific alert. Could be really interesting, and especially if it's some sort of a network triggered event. So there's also a couple other types of joins called outer joins. Now, an outer join is going to give you everything from the left or right table, depending if you use a left outer or a right outer join, regardless if there's a match on the right. And we're going to use a couple examples here. So in our left table, we've got foo, bar, baz, cooks. In our right table, we've got wibble, wobble, and wobble. So if we take our left table and we do a left outer join on the right table, what you're going to see is all the rows from the left are going to come back. But since we don't have a match for 3 and 4 in our right table, we're just going to get a null back for those rows. So this is super handy if you expect to have, if you want all the rows from one table, whether or not there's ones in the second table, but if there is, you want those rows as well. So let's go ahead and use this in practice. We're going to look at the email events table. So if you remember, so email events is going to contain a bunch of information whenever an email comes into Office ATP. It's going to contain information about the email's metadata. You're going to it's going to be have the determination as to whether it was identified as a potential phish or potential malware detections on the email, as well as if there's any action taken by Office ATP when that email was received. So did we block it or whatnot? You're also going to see email attachment info. This is the other table we're going to use here. So this is going to contain one row for each attachment that was associated with an email. Now, let's in the real world, a lot of times an email may come through. If it was a phishing email, either you might have a policy that's set a little bit too loosely, or maybe the attacker's using a brand new domain that we've never seen before. So let's say, so we have a capability in Office ATP called Zap. So let's go ahead and take a look and see, first off, so these would be emails here that we picked up as phishing on receipt. And we're going to do a left outer join on the attachments to see what attachments they came in with. So again, these would be ones that we saw with phishing, and it was picked up during the initial delivery to Office ATP. Now, what you'll see is you will have all of the phish emails that came through. And this is all the metadata for the actual phishing email, including how we detected it. And you'll see over here to the right, this is going to be all of the attachment information. So we've got an updated policy, so on and so forth. So, and you'll notice there's a bunch of nulls. So again, with a phishing attack, you don't always have an attachment. So this is a great way to see attachments for things that we classified as phishing emails, whether or not they have an attachment, and you can actually see what the attachments were. So in this case, so we use the left outer join to give us all the attachment information. Now we've got another kind of join here called a full outer join. A full outer join is going to link these two data sets together, regardless if they have a match or not. So doing a full outer join on these two tables, same ones as before, you notice we've got a 16 down here called wobble that has no match on the left table. So we're going to get all the rows from the right table and all the rows from the left table, and then they'll be linked together whenever the key matches. So this is pretty handy. Now, I'm going to show you a sort of a more advanced query here. This one's published in our GitHub. So this is one I use to check the antivirus version, so the engine version, the signature version, and the platform version. In this case, you'll notice we've got a full outer join here because we're basically parsing the command line to determine what the version information is. Excuse me. So we've got because we're using two completely separate queries here, and I want to link them together based on device ID, but I can't always be guaranteed that this process is going to launch within this time window in both cases. So I can't say for sure that we're going to have the AB launch that we need, the MP6 stub call, and the MSNP ENG call within that 7-day period, but I still want the data where it's available. So using a full outer join lets me ensure that we get all the information about the anti-malware engine version, the signature version, as well as the service version, regardless if one or the other did not bring back a result in that time frame. So it's a good real-world use for a full outer join. There is some other fairly advanced stuff that's in here. You'll see, for example, we'll be talking about this next episode. So the summarize operator. Basically, what we're doing in this case, though, is I'm saying get the latest timestamp by device ID and device name, for these, and also include the initiating process command line. So this is a way of deduplicating data. So we'll go into this a little bit more in the next episode on tracking the adversary. Special thanks to I don't have the original contributor's name on here, but they made the initial version of this, and we were able to modify it to have a little additional context. So we'll talk quickly about anti-joins. So an anti-join is sort of unique to KQL. Essentially, what it's going to do is it's going to remove values where the key matches. So in this case, we're going to do a left anti-join our two tables, which means we're going to take the rows from the left table and strip out wherever the right table has a matching key. So this is really handy if you want to filter down a data set. So if you, for example, if you want to filter one table based on the other, using an anti-join will only return one of the two tables, depending if it's a left anti or a right anti-join. So super handy if, for example, you want to remove, let's say you want to remove a certain type of user from the results from a query. You can query for that user and then use an anti-join to strip the accounts you would not want in your results out. Right anti-join is essentially the same thing, except for this time, we're going to return only the rows from the right table where they don't match something on the left table. As you can see, the only thing we got back from this query was wobble because there's no 16 in the left table. So if you remember earlier, I was talking about ZAP and those type of capabilities. So in KQL, we've got a table here called email post delivery events. And what this is this means the email was delivered to the mailbox, and then after the fact, maybe an administrator came in and zapped it, or maybe we identified this after the fact as a phishing or a malicious email. An email post delivery event is going to log a row every single time we have a remediation, a phish zap, or a malware zap for a particular email. So let's take a look and see where we have an email event where we saw it is that it was either a phishing email or a malware email, and we did not have a replace attachment or send to quarantine action when it was received. Remember, email events is when it arrives. But then we're going to use the left anti-join, so we still want the data from the left, where we basically removing information where we did not perform a malware zap or a phish zap or any form of remediation. So by running this query, we can see which things that were classified as phish or malware that might still be in that user's inbox. You can see here now what we have is a subset of rows where the malware was not removed or the phish email was not removed. This could be a policy issue. This could be too lapse of a policy. There's different reasons that this condition could exist. But in this case, we identified it as malware, and we did not go back and remove it after the fact, and it wasn't removed on receipt. So for all of your join details, this is the official location. So if you go to Cousteau query join operator, you've got a bunch of different types of joins that are available. So I'm going to talk a bit about unions. So unions are sort of like a join in a way. Unions are going to let you link together two queries, but instead of joining them on a key, you're just kind of appending one onto the other. So let's do a quick union here. So we're going to take the left table and the right table, and we're going to union them together. Now notice we've got same column names, key and value. So by running this, what we're going to get is a concatenated result of both tables. This can be handy if you don't necessarily want to link and add columns like an outer join or something like that. If you actually just want to have the same columns matched up where possible, that's where a union really comes in handy. Now, let's actually put this to practical use. So let's say we wanted to see any logons, basically whether it be a device login event or an identity login event for a given user. This is a great example of where we can use union. So by using device login events, I'm going to add a column here called table, and I'm going to set the device login events just so we can see that that came from the device login events side, paired with, and we're going to union it together with the identity login events. And once again, adding a column called table again, called identity login events. And we're going to go ahead and run this, and I'll show you how this can be fairly handy in searching across multiple data sets. So in this case, what we'll get back is the aggregate results of device login events and identity login events, and the columns where they match names and data types will be joined together into the same column. You'll no longer have that separate column essentially. And we can see that here. So notice we've got the first three rows came from identity login events, excuse me, and the fourth row came from device login events. But if you look, the account domain, the account name, the account UPN, wherever it matched up by type and column name are actually merged into the same column. So this gives you a single unified way to search multiple queries if you want, without having to worry about adding which table it actually came from. So we have one last thing here to talk about today, and these are functions. So now I'm going to see if I can click this little triangle over here and pop out my window. So a function is sort of like a join. In this case, right now we have one particular function called file profile. I know there are more coming in the works, but essentially what the file profile function is going to do is it's going to give you additional information about a file. So the way you use a function in KQL, especially these functions, there's different kinds of functions that are out there. It's ones you can call directly. This is what I would refer to as an invocable function. In other words, you're going to pass information into this function, and it's going to enrich the data in some way, shape, or form. So let's take a look here. So we're going to use the file profile is going to give you a bunch of information about the file's state. So this is not like when the file was written or if the file was used to launch a process. This is going to give you information about, for example, the first time we've seen it globally or the last time we've seen it globally. Or, for example, the signer or issuer. It's going to do a bunch of, if this is an authentic code signed binary, it's going to give you information about the signer, whether it was valid, if it's a Microsoft binary. We're also going to attempt to identify the software associated with it. So in this case, we're taking device process events. So something was launched on one of the devices. We're going to call file profile. Now, important note when you're using file profile, by default, it's going to require the SHA-1 column. So if you don't have a SHA-1 column in your source data, this is going to throw an error. So make sure you don't filter that out. There's also a way to do it based on SHA-256, which I believe, if I remember correctly, is to basically put SHA-256 in here instead of just leaving that blank. It's sort of like a parameter, if you would, and that'll match on the SHA-2 column instead. So we're going to take the processes and we're going to say where the global prevalence is not empty. This is just to make it because we're going to be getting the top results based on global prevalence. Nulls are going to be the essentially like treated like zeros in this case. So I'm going to strip out where the global prevalence is not empty. And I'm going to make sure we have where the global prevalence is less than 1,000. So this is a fairly low count file. In a real world scenario that's not this lab, you might crank this 1,000 number down to a couple of hundred. And then we're going to go ahead and reorder the columns just to make it easier to read. Just like a join, so this function is going to end up putting a lot of the columns you're going to be looking for off to the right, like the signer, issuer, all that information. But for this demonstration, I moved these all to the left to kind of make it a little bit easier to read. So we're going to take the top 100 results where the global by global prevalence in ascending order. So essentially, when we had a process created by what is essentially a rare file, and what you'll see here is, if I can click, come on. Essentially, what we're going to have is, there it goes. Click over there. So this is going to give us the rarest files that were used to create a process. So for example, this one was only seen 177 times in the world. It looks like a Python script, which is being run. It's going to be on a Linux box in this case. So really handy way to get some additional context about the files that we're seeing. So that covers our joins discussion for today. Tali, if you could pop on, are there any major questions or themes that were coming up in the Q&A?
Yes, sure. Thank you, Michael. So we have here a question on how to query for a list of IPs. For example, a network team just wrote a big list of address, and I want to check for different things and information regarding these IPs and activities that are involved. Awesome.
So this is going to be a little bit more advanced to get that. So there's an operator out there, and unfortunately, this is a hard one to do in a live demo, so I apologize for this in advance. There's an operator called external data. So I'm going to go over the operator itself because it would take me a little while to mock up a good example here. But there is external data will actually let you make the Cousteau cluster behind all this. Basically, make MTP, if you would, reach out to a web published data source. So now what I've done in the past, so data, here we go. And so the external data operator you can specify essentially a CSV or a TSV formatted list that's hosted somewhere publicly. It can't require authentication, by the way, because there's no way to really pass your identity through to that source. And then what you can do is you can import it essentially as a table. So that once you get the external data operator back, in fact, I think there's an example down here. Yes, this is, nope, these are examples using blob storage. So this is not the one I was looking for. So the other cool thing you can do here is use this for web service calls. So if you have an anonymous web service that returns a CSV or TSV output, and you want to include that as a table in your hunting, external data is going to be your friend for that. And as you can see, so this is a trick that I've used before, is using SAS tokens. So let's say the data is sensitive and you don't want to just expose it to everybody on the internet. What you can do is you can spin up an Azure storage account, a blob storage account, upload the CSV or TSV file to that storage account, and then grab a SAS token that provides read access and use that as essentially the URI you pass into external data so that you can import that securely into your advanced hunting query. I would do a demonstration, but as I mentioned, that's one of the ones it would take me a good while to put together a good demo, and the demo gods would definitely not be on my side that time.
Michael, maybe we can do an example just with a small list using the in operator, so they will get a feeling. And if you can please show which tables contain the information on IPs, what we should query on.
Absolutely. So if the information is not internal, like your own proprietary data source, there's a couple ways we can do it. So let's say, let's do device. Let's see. Let's do identity. Let's see, identity logon events. Take 100 of these. So there's a couple different ways we can do this. So there's one way where we can essentially use the anti-join, the semi-join, or the inner join. So let me go ahead and grab a handful of IPs. Let's see here. Okay, so I think we actually, if I'm correct, we have some. Sorry about that. It's taking just a second. There we go. So let's say we want to know the IPs that are coming from, I believe this is, Romania in this case. This is where location is equal to Romania. Let's say we wanted to reduce out any. Let's say we wanted to reduce out any device network connection events that had one of those IPs in it. So one way we can do this is we can set this to a variable, so distinct, say, address. So we can call these here. Let's bring up here. Let RO IPs is equal to this. So once again, we're using the let operator from last week's episode. We can say, and let's say we want to do a, we'll just do, to keep it easy, we'll do identity login events. And obviously there's this example is a little funny because you actually could do this with just a basic where clause. But let's do where IP address not in RO IPs. So in this case, we can filter out, and we're going to take, let's just take a couple of these here, take 100. So this is one example. So using the in or not in operator, we can filter it out using a where clause. Now, depending on the number of things you have in RO IPs, we can also use we can use an anti-join or a semi-join. So for example, let's say we wanted to see, in this case, we wanted to see the Romanian IP addresses only, and we wanted to use a join for this. So from here, let's just go ahead. Let's use a different table in this case. We'll join it together with device network events. I'm not sure anything's going to line up there, unfortunately, though. Join. So we're going to do a kind. In this case, we're going to do right semi. Kind equals right semi. Device network events. And in this case, device network events doesn't have an IP address column. So it's got a remote IP column. So what we're going to say $left .IP address, because remember, the left table is going to be identity login events. And we're going to do $right remote IP. Am I correct in this one? Let me double check myself. Device network events table. Should be remote IP. Yeah, remote IP. I'm not sure why we didn't get syntax hauling out of this one. So in this case, take 100. So what we're going to do is we're going to take the list of Romanian IP addresses we have here. What am I? Apologies for that. Oh, it's on. That's why I forgot. There we go. That's why it wasn't coming up. Forgot the on statement. So in this case, what we'd be doing is we'd be taking the list of the IP addresses that came from Romania from identity login events, and using a right semi-join, which means we're going to get the results from the device network events table back wherever these did not match. So if you notice this did match in this case, since we're doing a semi-join, we're going to basically say only give us results where from the right table where the IP address from the left table matched the remote IP field on the right table. So in this case, essentially what we're finding out is that there was nothing that from a Romanian IP address on the identity login events that matched a remote IP on the device network events. So kind of a funny example there, but you can kind of see the logic behind it. That's how you would do it with a join in this case.
Thank you, Michael. Another question we got is how we can get logs of PowerShell related activities. So,
okay, that's a good question. So there's a couple different ways you can do it. So there's the way that works cross-platform, which is going to be based on device process events. That's going to give you, so for example, device process events, where file name. And there's a couple different tricks here. So if you're looking for true adversary activity, they may have renamed PowerShell, so you might want to go in there and check all different file hashes for PowerShell and compare it to that PowerShell. There's a couple different ways you can do this, but for right now, we're just going to do a simple one. So PowerShell.exe. And from here, we can do a distinct, let's just do distinct process command line. So this is, and we're just going to, for now, we're just going to take 100 of these. So this is going to work cross-platform on anything that could send data into MTP, and specifically Defender ATP. And you can see we've got some activity here. So remember, since I used the distinct, it's only going to bring back one row per process command line, and it's going to strip out. Oops, I just switched out my letters here. It's going to strip out all the other columns because I didn't specify any other columns. So that's one way to do it. There's also a way that works on Windows 10, which is the uses what's called the AMSI, or the anti-malware scanning interface. So there's a table we haven't really talked about yet called device events. And from here, so what AMSI does, AMSI is going to essentially, so attackers will commonly obfuscate or encrypt or try to hide their logic in scripts by changing it and messing around with it, so it's not easy to scan. The AMSI feature of Defender basically will figure out what that script will be after all the deobfuscation, and then log what the script would have been, when it was run. So that enables us to scan the script after any deobfuscation has been cleared up. Really great from an anti-malware perspective. In this case, I got to remember the exact one. I think it's PowerShell command, if I remember right. So device events is sort of a bucket where a lot of different things exist. So you're going to see where's action type. So there's in fact, let's do this right now. Let's take a look. Distinct action type. So we'll take a look at some of the different actions that are in here. One of them is going to be PowerShell command. Yep, PowerShell command right there. You can see there's like remote desktop connection. You can see when somebody calls read process memory by API. You can see driver loads, all kinds of good stuff. But in this case, we really want to see PowerShell commands. So where action type is equal to PowerShell command. And we're going to take a few of these. 9,009, just 100 should be good. And hit run. So what you're going to see in the results is each individual commandlet that was run by a PowerShell script, regardless if it was in a PS1 file or from a one-liner. It'll all be logged as long as you ran it on a Windows 10 box with their AV and such on it. So once this comes back, you'll see over here to the right. Wait for my interface to come back. Sorry about it. Taking just as there it goes. This is the joy of doing live demos. So over here to the right, we should see the specific. Okay, these have been. So this is a specific script that was being called in this case. But here we go. So write ETW trace, out null, test path, get remaining time. So you can see the individual commands. Now I can get a little bit more advanced here. So we're going to turn this into a dynamic. So a dynamic we talked about in episode 1. It's essentially an object-oriented field inside of KQL. So we're going to go ahead and extend a field. We're going to call it command is equal to parse JSON. And we're going to pass it additional fields. Okay, actually, we'll call this one second. Command dynamic. And then we're going to do from here is actually we'll just go. I'll just make it. Yeah, I'll make it easier here. And then we'll do project timestamp. We'll do the device name. And then we'll do. We want to get the actual command out of that. So command is equal to. If you remember from project from last week, project is going to only supply these rows, but you can actually rename rows or calculate. So I'm going to use the calculate feature here to take command dynamic, and I'm going to grab the command field. So if you see here, there's a key value association here in JSON. So we're going to get back command, and the value is going to be get update KBID. So let's take a couple of these here. And what you'll see is we're going to actually turn this into JSON, extract out the specific command that was being run, and there you go. So the command will actually just show you what was inside the command field. Again, this is a Windows 10. This is a Windows 10 capability, I believe, Server 2019. Good to go. I know we're getting pretty close to time. Do we have another?
Yes, few more questions.
Sure.
How can you access user properties from Azure AD?
From Azure AD. So if you remember, we have the identity info table up here. So identity info is going to be, okay, identity info. We're going to take a few of these here. So this is going to be a list of all the different user accounts that are in Azure AD and some of their common metadata fields that you're going to want to search and filter on. Now, we used this one earlier in our demo to when we were searching for users that are in the finance department. We came back with Barbara's account. But in this case, you can see we've got account UPN, on-prem SID, this is your Active Directory SID, if you would, Cloud SID, which is going to be an Azure Active Directory concept. You've got the given name, surname, oops, there it goes, sorry about this, lagging a little bit here. The account's display name, department, job title, a bunch of good information about each individual user. Is the account enabled, for example? So there's a bunch of information out here in the identity info table. So if you're trying to search for users that are in a specific department per se, this is a great way to do it. If you want to search for users who have a specific first name, last name, email address, SIP proxy is essentially how your Teams is going to be communicating, or you can do it by location. You can see we've got Redmond, United States. Again, this is going to have to be populated in Azure AD for this to be popular. This isn't like location detection in this case. All right, good to go. Well, thank you all for joining. Let me go ahead and switch back to our slide deck. We've pause for just a minute here. So again, definitely so looking forward to our next episode, where we're going to start getting into the summarizing, pivoting, and visualizing data. So this is going to be a pretty advanced topic. We're going to get into summarize, we're going to get into make series, we're going to be doing series anomaly detection, all kinds of good stuff, and summarizing, and also graphing it all out. So there's visualization capabilities built into MTP that'll enable you to show essentially what the data looks like in a column chart or a pie chart or a line chart. So a bunch of good stuff coming next week, and looking forward to seeing you there.
Thank you, Michael. So some reminders before ending the call. Our next scheduled webinars are on the next one, July 28th, which is Azure Sentinel KQL hands-on lab experiences. Then July 29th, which Michael just announced, which is the episode 3, summarizing, pivoting, and visualizing data with advanced hunting in Microsoft Threat Protection. And August 5th is then the end of this webcast series for advanced hunting. Episode 4, Let's Hunt, applying the KQL to incident tracking. And more webinars are actually scheduled throughout mid-September, and for details and registration, just go to aka.ms/security-webinars. If we missed to answer your questions, or if you have additional questions, you can visit the Microsoft Threat Protection Forum at aka.ms/mtptc. And again, thank you, Michael, for a fabulous demo-only presentation, and I'm really looking forward to episode 3 next week. Thank you, of course, to the rest of the team who helped answering the questions. And most of all, I want to thank all of you for being part of our community and for joining us on these webinars. We hope to see you next time. Goodbye.